Hello viewers, welcome to my channel. I'm Hasham Ali Khan. In this video, I'm going to start the problems on seasonal variations. In the first video, I have explained you the components of time series. The components of time series are secular trend, seasonal variation, cyclical variation, and irregular or random variations. So these four are called the components of time series. So we have done the problems on secular trend. In the last so many videos I've explained you, we have done the problems on all the four methods of secular trend. That is freehand method, semi-average method, moving average method, least squares method, and second degree parabola, shifting the origin, changing the trend. All these things we have done in the last so many problems. Last few more videos I'm going to make on seasonal variation. The second component of the time series, seasonal variation. The seasonal variation shows the changes in the values in the variables within 1 year, and these fluctuations in the variables within 1 year will get repeated year after year. That means the same pattern of changes will be repeated from 1 year to another year. It will be continued repeatedly. Example, in many cases we can see seasonal demand for the goods. The goods demand will be seasonal during a particular season. Example, the demand for umbrellas, the raincoats, the demand will be more during June and July, particularly in India. In India, the demand for umbrellas, raincoats will be more during June and July because monsoon is there. During the peak of the monsoon period, more demand for umbrellas. As soon as monsoon is over, the demand of sales of umbrellas and raincoats will come down. Similarly is the case for cotton made cloth. The cotton made garments, the demand will be more during summer season. So as soon as the summer is over, the demand for cotton cloth will come down. So many cases, similarly the price of agricultural produce. The price of agricultural produce will come down during the harvest season. As soon as the harvest is over, the prices may increase. The same pattern of changes will be repeated year after year. These are called seasonal variations. And the study of seasonal variation is very, very important for the business people because they have to make the planning. The businessman has to make the planning. What are the variations that are going to take place in a particular month according to the past experience? Because accordingly they have to plan for production. They have to plan for marketing, they have to plan for finance. All different short-term plannings are required based on seasonal variations. So how to calculate the seasonal variations? There are four methods. Simple average method, ratio to trend method, ratio to moving average method, and link relative method. These four methods are there which are applied to measure the seasonal variations. Now I am going to start the problems on seasonal variations. So before starting the problems, I expect my viewers to have a printout of the problems which I have given in the link under my description. So take a printout and keep it ready. The first problem on seasonal variation I am reading out. Given the seasonal averages, calculate seasonal index numbers by applying simple average method. By applying simple average method, we have to find out the seasonal indexes of the four seasons given. The four seasons are summer 45.6, monsoon 177.75, autumn 102.40, winter 209.6. The averages of every season is given. So we have to calculate the seasonal indexes for the year, for all the four periods. The simple average method. First of all, summer average. It is given in the problem. Summer average 45.6, monsoon average 177.75, autumn average, winter average. All the averages are given in the problem. We'll take the total of the average. The total of the averages are 535.75. So how many items we have taken? 4 averages we have taken. So we'll calculate the grand average. The average of averages is called grand average. So 535.5 divided by 4 will get 133.8375. So 133.8375 is the grand average, average of averages. Now we have to calculate the seasonal index number. The seasonal index number for each season we have to find out. The first season Summer. Summer season, what is the average? 45.6 is the average. What is the grand average? 133.8375. So 45.6 divided by 133.8375 into 100. 34.07 is the seasonal index. For which season? Summer season. Same procedure for monsoon. Monsoon average is 177.75 divided by grand average 133.8375 into 132.81. This is the seasonal index for monsoon. Now autumn. The autumn average is 102.40 divided by grand average into 100, 76.51. This is the seasonal index for autumn. Last one is winter. Winter season average is 209.60 divided by grand average into 100, 156.61. That's all. These are called the seasonal index number for each season according to simple average method. So starting 4-5 problems I am going to apply on simple average method. So how to calculate? Whatever the averages are given, take the grand average. The average of the season divided by grand average into 100. You will get the seasonal index numbers. That's it. Now I am coming to the second problem. Problem number 2. Find seasonal indices by simple average method from the following data. Year 1998, 99, 2000, 2001. For every year, quarters are given. First quarter, second quarter, third quarter, fourth quarter. Previous problem and this problem, the difference is, in the previous problem, average of each season was given. Here, average of each quarter is not given. We have to calculate the average of each of the quarters. 4 quarters are given. First quarter values are given for 1998, 99, 2000, 2001. 4 years data is given. 4 years data is given for each of the quarter. So we calculate the average of the quarter. We calculate the grand average of the quarter. Then easily we can calculate the seasonal index numbers. Now, finding the seasonal indices by simple average method. Year 1998, 99, 2000, 2001, 4 years. Quarter 1, 2, 3, 4. As it is, whatever is given in the problem, same table I have prepared. I have calculated the total. Total of quarter 1, total of quarter 2, total of quarter 3, quarter 4. Then this total is divided by 4 because 26.4 is the total of how many values? 4 values. There are 4 values, 4 years are there. So 26.4 divided by 4, you will get the average 6.6. The first quarter average 6.6. We have calculated the average of the first quarter. Similarly, calculate the average of the second quarter. Take the total 27.8 divide by 4, 6.95. 8.475, 8.125. These are the average of first quarter, second quarter, third quarter, fourth quarter. Now we will calculate the grand average. The grand average, take the total of the averages 6.6 plus 6.95 plus 8.475 plus 8.125 divided by 4. How many values do we have? 4 values. So divide by 4, you will get 7.5375. This is called the grand average. Grand average. Now we calculate the seasonal indices. So seasonal indices of each quarter. First quarter. What is the average of the first quarter? 6.6. What is the grand average? 7.5375. So 6.6 divided by 7.5375 into 100. 87.56 is the seasonal index for first quarter. Second quarter, 6.95. The average is 6.95 divided by 7.5375 into 100. 92.21 is the index number for second quarter. Third quarter, 8.475 divided by 7.5375 into 100, 112.14. Last quarter, 8.125 divided by 7.5375 into 100, 107.79. That's all. This is called the simple average method of calculating seasonal indices. So 2 problems we have completed. Now see the third problem. Exactly similar. Calculate the seasonal index from the following data using average method. Average means simple average method. Year 1992, 93, 94, 95, 96. So 5 years data is given for each of the quarters. Quarter 1, 2, 3, 4. Exactly similar to the previous problem. Here 5 years data was given. Previous problem 4 years data. That is the only difference. Procedure exactly same. So calculating seasonal indices year 1992, 93, 94, 95, 96, 5 years. The values are given for each of the quarter. Take the total of the quarter. The first quarter total 376. Now tell me 376 is the total of how many values? 5 values. Here 5 values are there. 72, 76, 74, 75. So 376 divided by 5, you will get 75.2. Similarly 352 divided by 5, 70.4. 416 divided by 5, 83.2. 384 divided by 5, 76.8. These are the average index numbers for each of the quarter. Now we calculate the grand average, average of averages. So 75.2 plus 70.4 plus 83.2 plus 76.8 divided by 4. Because 4 numbers are there, 1, 2, 3, 4. So grand average is 76.4. Now average divided by grand average into 100, you will get seasonal index. So seasonal indices of each quarter. First quarter 75.2. 75.2 divided by 76.4 into 100. 98.43. Similarly 70.4 divided by grand average into 100. 83.2 divided by grand average, you get 76.8 divided by grand average, 100.5. That's all. These are the index numbers of each of the quarter according to simple average method. Now I am reading out the fourth problem. See the fourth problem carefully. Exactly similar. From the following data relating to the number of letters posted in a post office, find the seasonal variation within the 5 weeks by using method of simple averages. Weeks. Weeks are taken in the first column. 1, 2, 3, 4, 5. 5 weeks are there. And number of letters posted on each day. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So all the 7 days of the week, the data is given. For first week 7 days, second week 7 days, third week 7 days, all the data is given in the problem. We have to calculate what is the seasonal index for each day of the week. Each day of the week. Sunday. Take the total of Sunday 108. So 108 is the total number of letters posted. For how many weeks here? 5 weeks. 5 weeks are there. This 108 divided by 5, you will get 21.6. This Monday total 821 divided by 5, you will get 164.2. The total Tuesday 886 divided by 5, 177. Like this, we have calculated the average number of letters posted on each of the weekday. Now we can calculate the grand average. Average of averages is called grand average. Take the total of all these averages, divide by 7, because 7 days are there. 1, 2, 3, 4, 5, 6, 7. 7 days of the week. So divided by 7, you will get 137.17 is the grand average. Now seasonal index is equal to average divided by grand average into 100. So average is 21.6. So 21.6 divided by 137.17 into 100, 15.75. Similarly, for every day, take the average in numerator, grand average in the denominator into 100. 164.2 divided by 137.17 into 100, 119.71. The next one is 177.2 divided by 137.17 into 100. So in this way, we'll get the seasonal index for each day of the week, from Sunday to Saturday, like this. So we have completed 4 problems on seasonal index. Come on, now we'll start the next problem. Problem number 5. Consumption of monthly electric power in millions of kilowatt hour for street lighting in India during 1971 to 75 is given below. So year 1971, 72, 73, 74, 75, 5 years data is given. So January, February, March, April, May up to December. So complete 12 months. For every month, how much was the monthly electric power consumed? That is given 1971, 72, 73, like that. Find out the seasonal variation by the method of monthly averages. That means simple average method. So previous problems, also 4 problems we have done on simple average, seasonal variations by simple average. This is also The same problem, we have to calculate simple average, monthly simple average. Exactly similar to the previous problem. So calculation of seasonal indices by simple average method. So year 1971, 72, 73, 74, 75, 5 years data is given. For every year 12 months data is given. 12 months from January to December. So we are taking the average. Take the total of the 5 years, that is 2, 3, 4, 5. 2, 3, 4, 5 is the total of January month for 5 years. Right? Now divide this total by 5 because this is the total of 5 values. So divide it by 5. You will get the average. 469 is the average of January. Similarly, February total 2160. Average is 432. The total of March is 2130 divided by 5. You will get the average 426. Like this, you have calculated the average of every month from January to December. Now we can calculate the grand average. Grand average means the average of the averages. The average of averages. Take the total of all the averages. 469 plus 432 plus 426, like that you add up all the averages, divided by 12. Divided by 12. You will get 414.25. So 414.25 is the grand average. Now, seasonal indices. Take the average of the month divided by grand average into 100. What is the average of month of January? 469. So 469 divided by grand average 414.25 into 100. So 469 by 414.25 into 100. 113.22 is the seasonal index for January. Similarly for February. February average is 432. So 432 divided by 414.25 into 100. 104.28. This is the seasonal index for Feb. Now March. 426. 426 by 414.25 into 100. 102.84. Like this, you have to calculate for all the seasonal indices up to December. So December seasonal index 115.6. That's all. So this is the end of problem number 5. Now see the problem number 6. The first 5 problems are on simple average method. Simple average method. Now 6th problem onwards we have a ratio to trend method. Second method I am coming to the second method, a ratio to trend method. So calculate seasonal index number from the following data. Ratio of observed to trend percentage. Already percentages it has calculated. There is no need to calculate percentage. Ratio of observed values to trend values. Percentage is given. Year 1991, 92, 93, 94, 95, 96. 6 years data is given. Quarter number 1, quarter 2, quarter 3, quarter 4. So every year 4 quarter values are given for 6 years. Now we have to find out the seasonal index number using ratio to trend method. So now see carefully. Calculation of seasonal indices, ratio of observed to trend values. Ratio of observed to trend values are given. So year 91, 92, 93 up to 96. The quarters value, these are the ratio of trends. Quarter 1, 2, 3, 4. Take the total and calculate the average. This 552 is the total for first quarter. For how many years? 6 years. 1, 2, 3, 4, 5, 6. So divide by 6. 552 divided by 6, 92. 696 divided by 6, 116. 618 divided by 6, 103. 534 divided by 6, 89. That's all. So the steps of calculating trend equations, finding trend values and expressing the original factor as a percentage of trend is already completed. Only the final stage of calculating seasonal indices is to be completed. So in this problem, already they have calculated the trend values. They have calculated the percentage of actual values over trend values. Percentage of actual values over trend values already calculated. Simply you have to come to the final stage. Final stage is calculating seasonal index. So this average is the seasonal index. 92 is the seasonal index for first quarter. 116 second quarter. 103 third quarter. 89 fourth quarter. So these are Q1, Q2, Q3, Q4. First quarter, second quarter, third quarter, fourth quarter. Seasonal index. That's all. So this is the end of problem number 6. Come on, now we'll start the next problem. 7th problem. Already two methods we have applied in the previous problems. The first method, simple average method. Second, ratio to trend method. Now third method is ratio to moving average method. For calculating seasonal variations, seasonal indexes, we are applying ratio to moving average. Seventh problem, calculate the seasonal index by the ratio to moving average method from the following data. Year 1972, 4 quarters are given, quarter 1, 2, 3, 4. In 1973, again 4 quarters, 1974, 4 quarters, 1975, 4 quarters. The 4-year data is given, every year 4 quarter values are given. The values are 75, 60 like that. All the values are given for each of the 4 years for 4 quarters. And 4 yearly moving averages. 4 yearly moving average is also given. No need to calculate the 4 yearly moving average. Moving average is also given in the problem. Now see how to find out the seasonal index using ratio to moving average. Moving average method, year 1972, 4 quarters, 1, 2, 3, 4. 73, 4 quarters, 74, 4 quarters, 75, 4 quarters. That is given in the problem. And for each of the quarter, values of y are given. All these values are copied down from the textbook, from the question paper. Now 4 yearly moving average. This 4 yearly moving average also given in the problem. The first quarter we don't have any values, second quarter we don't have. When we are calculating 4 yearly moving average, then first 2 period, last 2 period will be lost. The first 2 quarters, last 2 quarters data will not be there. So we are given the value. Now adjusted seasonal variation. How to find out adjusted seasonal variation? Actual value divided by moving average into 100. What is the actual value of third quarter here? 54. What is the 4 yearly moving average? 63.375. So adjusted seasonal variation, here I have given the formula. Adjusted seasonal variation is equal to 54 divided by 63.75 into 100. 85.2071. So 54 divided by 63.375 into 100, you will get this one. 59 divided by 65.375 into 100, you will get this value. 86 divided by 67.125 into 100, you will get. So these are called adjusted seasonal variations for each of the quarter we have calculated. First 2 quarter we don't have the data, last 2 quarter we won't have the data because we are following 4 quarters. Now, computation of seasonal indices. 1972, first quarter, second quarter we don't have the adjusted seasonal variation. We don't have the data for first quarter and second quarter of 1972. Third quarter we have 85.201, fourth quarter 90.2486. For 1973, all the 4 quarter values we have. 1974, all the 4 quarters value. 1975, we have the first quarter and second quarter. 117.4551 and 92.7536. We don't have the value of the third quarter and fourth quarter of the last. Now take the totals of these 3 values. Total of those 3 values we have taken. Now average. 363.0294 divided by 3, you will get 121.0. This total divided by 3, because 3 values total is this one, we'll get this value. So we got the average. If you get the average 400 here, because every quarter the average is 100. So 4 quarters 400. You should get 400 here. But we are not getting 400. We are getting 398.0961. It is very near to 400. So we have to adjust it. So how to find out adjusted seasonal index? Take the actual index, average, divided by grand average into 400. So what is the average here? 121.01. What is the total of these averages? 398.0. So 121.01 divided by 398.0961 into 400. You will get 121.5887. This is the index for quarter 1. Similar for quarter 2, 92.406 divided by 398.0961 into 400, 92. Similarly, we have to calculate for Q3 and Q4. The total you must get 400. These are the seasonal indices according to moving average method. That's it. This is the end of problem number 7. Now see the 8th problem. Problem number 8. Calculate seasonal index by ratio to moving average method from the following data. Exactly similar to the previous problem, but here the data is given, but 4 quarterly moving averages are not given. Previous problem 4 quarterly moving averages were given, but here we have to calculate 4 quarter moving average. After calculating 4 quarter moving average, then we have to proceed for finding out seasonal indexes. So slightly different problem compared to previous problem. Here we have to calculate 4 quarterly moving average. So moving average method, year 1996, quarter 1, quarter 2, quarter 3, quarter 4, 4 quarters. 97 4 quarters, 98 4 quarters, 99 4 quarters. All the values are given in the problem. For 1996, the 4 quarters values are given: 290, 280, 285, 290, 280, 285, 310. Next, 1997, 4 quarter values are 320, 305, 320, 305. So same from the problem, I have copied down the data for all the years, all the quarters. Now, 4 yearly moving total, 4 quarterly moving total, actually 4 not yearly, 4 quarterly moving total. So 290 plus 280 plus 285 plus 310. If you add up these 4, you will get 1165. So 1165 is the total of the first 4 quarters. Now include the next one, 1165 plus 320 minus 290. You will get 1195. Or directly you calculate 280 plus 285 plus 310 plus 320. This 4, you will get 1195. Leave then one more and then 285 plus 310 plus 320 plus 305. You add up 1220. Already moving average method we have done in the previous video also. Same method. So this is the 4 quarterly moving total. Now 2 period moving total, because it is not centered. This 1165 is not relating to a particular quarter. It is falling in between Q2 and Q3. Q2 and Q3, in between this we are getting 1165. Now to make it centered, we are making a 2 period moving total. So 1165 plus 1195, add up these 2 and put it in the center. 2360 is falling against Q3. Against Q3, we are getting 2360. Then add up these 2, 1195 plus 1220, add up these 2, you will get 2415. Put it in the middle, Q4. So we are getting centered value, 2 period moving total, 2360, 2415, 2465 like that. Now divided by 8, 2360 divided by 8 will get 295. Why 8? Because this is the total of first 4 quarters and this is the total of second 4 quarters. So first 4 quarters, second 4 quarters, that means 8 quarters. This total is for 8. So 2360 divided by 8, you will get 295. 2415 divided by 8 will get 301.87. This is the 4 quarterly moving average. Instead of yearly, we can write 4 quarterly. Here also 4 quarterly. Right? So we got 4 quarterly moving average. Now adjusted seasonal variation, same. What is the actual value here? 285. Actual value is 285. So 285 divided by 295 into 100, 96 point. Similarly 310. 310 divided by 301.875, 102. So actual value divided by moving average into 100. Actual value is 285 and the moving average is 395. 285 divided by 395 into 100, we'll get this one. 310 divided by 301.875, you will get this one. Like this you have to calculate adjusted seasonal variation. Exactly similar to the previous problem. Now computation of seasonal indices. Same year 1996, 97, 98, 99. Then quarters 1, 2, 3, 4. All the adjusted seasonal variation values we got it here. First 1996 there is no data for Q1 and Q2. So put a dash in Q1, Q2. Third quarter 96.61, 102.69. Then 1997 all the values. 1998 all the values. 1999, we have Q1 and Q2. We don't have Q3 and Q4. Q3, Q4 dash. Take the totals. Totals you have taken. Now 312.87. This is the total of 1, 2, 3 values. So divided by 3, we'll get 104.29. 293.95 divided by 3, you'll get 97.98. Like this, you got the averages. Now the total is 400.17. If we get exactly 400, then our answer will be stopped here itself. This average itself will be the seasonal indices. But the total is coming 400.17. So we will interpolate. We'll interpolate and calculate the correct value. So 104.29 divided by 400.17 into 400, we'll get 104.25. Similarly, 97.98 divided by 400.17 into 400, 97.5. Like this, you calculate for Q3 and Q4. Take the total, you must get 400. That's all. So this is the end of problem number 8. So we have completed 8 problems on seasonal variations. The first 4 problems we have done on simple average. One problem we have calculated on ratio to trend method. Then these 2 problems are based on moving average method. So if you are satisfied with my lecture, give a like to the video, share the channel in your group, in your friend circle, so that more students can watch the video and enhance the knowledge. And give your comments on these videos. Lastly, don't forget to subscribe my channel. We'll continue the next problem in the next video.